This is a video walkthrough of Practice 3E. For each of the following word problems, we're going to write a system of equations to represent the situation. Then we're going to translate that into an augmented matrix, and finally use the calculator to find the reduced row echelon form of the matrix, and then answer the question. So there's really a four-part process that we're going to follow, and we're going to show each of those results. All right. So, our first question is about a boat traveling downstream and upstream. What we need to remember about that is that we're going to organize the information using our typical distance, rate, and time situation. Our distances are in miles, times are in hours, so that means that our rate will be measured in miles per hour. And then we'll multiply that by the number of hours that the traveling happens, and the result is going to be the number of miles that are traveled. Organizing this information into a 3-column chart with 2 rows, we have a trip downstream, and then we have a trip back upstream. So the thing that we need to remember is that our rate of the boat in still water is not actually how fast the boat is going to travel. So the rate in still water will be added to the speed of the current if we're traveling downstream or with the current, and then when traveling upstream, the speed of the current is subtracted from that rate. So the trip downstream takes 2 hours, and we go 28 miles, and then the trip upstream, we only travel 18 miles, and it takes 3 hours. So if you use the formula up at the top, the miles per hour times the hours is 2 times r plus c, and that equals the number of miles, 28. For the trip upstream, 3 times r minus c, the rate times the time, is equal to 18, the number of miles traveled. We're going to go ahead and put that in standard form. When put in standard form, 2r plus 2c is equal to 28, and then 3r minus 3c is equal to 18. We can write that as a matrix. There are only 2 variables, so 2, 2, 28. Vertical line goes for the equal sign, or stands in the place of the equal sign, and then second row is 3, negative 3, 18. We're going to write that in reduced row echelon form, and when we do write that in reduced row echelon form, the result on the left side of the vertical line is going to be that identity matrix with the diagonals equal to 1 and all other entries 0. Let's see what the calculator gives us when we write the reduced row echelon form. So I'm going to type in the letters RREF, open parentheses, and then use the menu key to the right of the 9 to enter a 2 by 3 matrix. And then let's enter in the original matrix, 2, 2, 28 across the top, tab to the bottom row, 3, negative 3, 18 across the bottom row, and that gives us 10 and 4. And that means that r, our first variable, is equal to 10, and c, the second variable, is equal to 4. So r is the rate in still water. So in still water, the boat's speed is equal to 10 miles per hour, and the speed of the current is equal to 4 miles per hour. I'm going to box that in so that the grader can find my final answer. Make sure that you're showing your system, the augmented matrix put into the calculator, and then the resulting reduced row echelon form matrix that the calculator gave. All right, let's take a look at number 2. Similar problem. This is a tailwind headwind problem. We're flying in the air. However, the process is really the same. So this is going to be a distance, rate, time problem. we have miles per hour are the units of the rate, and that will be multiplied by hours, and the result will be measured in miles. So that's going to help us organize our information. And we have a first trip that involves a tailwind, and then the second trip which involves the headwind. So what we do know about this is that the helicopter has an airspeed, and the speed of the wind either helps or hinders the helicopter. So the speed of the helicopter is r in still air, and then we're going to add to that the wind speed when we have a tailwind, and when we have a headwind, the speed of the wind will be subtracted from that rate. With the tailwind, the helicopter traveled 300 miles in 1 hour and 40 minutes. That's 1 2/3, which can be written as an improper fraction 5/3. And then the return trip along this against the same wind took 20 minutes longer. So the return trip was the same distance, and if it took 20 minutes longer, that would be a total of 2 hours. So when we write our system of equations, I'm going to go ahead and do the distributing. 5/3 times r plus 5/3 times w, that's the miles per hour times the hours, is equal to the number of miles, which is 300. And then for the second equation, 2r minus 2w is equal to 300. Let's write that in matrix form. 5/3, 5/3, 300 across the top row, vertical line for the equal sign, and then 2, -2, 300 is our bottom row. When we write that in reduced row echelon form, the calculator should give us the following format. Let's enter that in reduced row echelon form. That would be RREF, and then open parentheses, and the matrix menu. We're going to enter a 2 by 3 matrix, and the original matrix has entries of 5/3, 5/3, and 300. And then on the bottom row, 2, -2, and 300. And that gives us 165 and 15. And 165 is the value of the first variable r. So r is 165, and w is 15. W is our wind speed. So the helicopter's airspeed, or the helicopter speed, if you want to think of it that way, is 165 miles per hour. And then the wind speed is 15 miles per hour. And I'm going to box my answer in. In number 3, we have a track meet, and there are 20 individual event placers. That means the number of first, second, and third placers in each event, and they're earning a combined total of 68 points. A first place finish earns 5 points, a second place finish earns 3 points, and a third place finish earns only 1 point. Parrish had a strong second place showing with as many second place finishes as first and third combined. How many kind of each finish did Parrish have? So I'm going to let F equal the number of first place finishes, S equal the number of second place finishes, and T equal the number of third place finishes. So what we know is that there are a total of 20 individual event placers. That means the total number of first, seconds, and thirds. So that's one of our equations. The number of firsts plus the number of seconds plus the number of thirds has to equal a total of 20. And then the next piece of information that we have is that their point total is 68 points. Well, each first place finisher earned 5 points. So 5 times the number of first place finishers is the number of points earned by the first place finishers. the second place finishers each earn 3 points, and the third place finishers earn 1. So 1 times t is t, and that total should equal 68 points. And then the last part is that we have as many second place finishers as first and third combined. So that means that the number of second place finishers is equal to the number of firsts plus the number of thirds. That equation is not in standard form, the very last one, so I'm going to rewrite the system so that it is in standard form. F plus S plus T is equal to 20. 5F plus 3S plus T is equal to 68, and subtracting F and T from the left side, we have negative F plus S minus T is equal to 0. Let's write that in matrix form. 1, 1, 1, 20 on our top row, 5, 3, 1, 68 on the middle row, negative 1, 1, negative 1, 0 on the last row. When we get the reduced row echelon form, the left side should look like a series of diagonal ones with all the other entries being 0. Let's place that in the calculator and find out what we get. RREF, open parentheses, and then use the matrix menu to enter a 3 by 4 matrix. And let's enter our original matrix coefficients or elements. And press enter. And we get 7, 10, and 3. That first value 7 is the value of the first variable. So F is 7, S is 10, and T is 3. So that means that there are 7 first place finishers. There are 10 second place finishers. And that there are 3 third place finishers. In number 4, Billy's Restaurant ordered 200 flowers for Mother's Day. Carnations are $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations, 20 fewer roses than daisies, and the total order came to $589.50. How many of each type of flower was ordered? So I'm going to start by letting the number of carnations equal C, and then R equals the number of roses, and then D equals the number of daisies, and they ordered a total of 200 flowers. So that means that the number of carnations plus the number of roses plus the number of daisies has to add up to 200. There's one equation. And then there's the pricing. So actually, that's not this next sentence. It says they ordered mostly carnations and 20 fewer roses than daisies. Mostly carnations is not something that we can really quantify. That's more of a qualitative statement. So we're going to stick with the quantification, which is 20 fewer roses than daisies. So that means that the number of daisies is the larger number. So that means that the number of daisies is equal to the number of roses plus 20, since the number of daisies is larger. That's going to have to be moved into standard form eventually here. And then we have the pricing. So the cost of the carnations is $1.50 times the number of carnations. And then add to that, the price of the roses is $5.75 times the number of roses. And add to that $2.60 times the number of daisies. And that total price should be $589.50. 50. Okay, we're going to have to move that second equation into standard form. When we write it in standard form, it will be written as negative r plus d is equal to 20. So now let's take and move this into a matrix form. C plus r plus d is equal to 200. And then our second equation, we have to use the standard form. There are no c's in that equation, so negative 1r and 1d, and that's equal to 20. And then on the last row, that's already in standard form, 1.5, 5.75, 2.6, and 589.50 is the last element. And now we're going to transform that into reduced row echelon form. And we already know what that left side of the matrix is going to look like. So let's let the calculator show us what the right side is going to look like. RREF for reduced row echelon form, open parentheses, and then enter the matrix in there. That will be a 3 by 4 matrix. And the elements across the top row are 1, 1, 1, 200, 0, negative 1, 1, 20, and 1.5, 5.75, and 2.6, and 589.5. You can leave the 0 off if you wish, or you can type it. And that's going to give us 80, 50, and 70. And we have to be careful what order here. 80 is the number that corresponds to C, 50 is R, and 70 is D. So that means that there are 80 carnations, 50 roses, and 70 daisies. In number 5, we have a coin collection. There are 14 coins with a total value of $1.35. The coins are nickels, dimes, and quarters, and the number of nickels is 3 less than twice the number of dimes. We are looking for the number of each coin in the collection. So let's let n equal the number of nickels, d equal the number of dimes, and q equal the number of quarters. There is a total for the number of coins. So the number of nickels plus the number of dimes plus the number of quarters has to total to 14 coins. And then there's a total value here. The value of the nickels is the value of 1 nickel times the number of nickels. The value of the dimes is the value of 1 dime times the number of dimes. And the value of the quarters is the value of 1 quarter times the number of quarters, and that total value is $1.35. You can do this in cents if you wish, and that in cents that would be 5n plus 10d plus 25q equals 135 cents. The third equation, the number of nickels, that's n, is 3 less than twice the number of dimes, so that would be 2d minus 3. That last equation will have to move into standard form, so let's do that right now. That would be n minus 2d is equal to negative 3. When we write this in matrix form, 1, 1, 1, 14 across the top row, 0.05, 0.1, 0.25, 1.35. If you're using cents, that would be 5, 10, 25, 135. And then the last row is the one that we moved into standard form. The coefficient of n is 1, the coefficient of d is negative 2, and the coefficient of q is 0. And on the other side of the vertical line is the number negative 3. Let's move that into reduced row echelon form using the calculator. I know what the left side is going to look like. Let's use the calculator to figure out the right side. And we're going to type in RREF for reduced row echelon form, open parentheses, and the matrix menu to the right of the 9 key. And then type in the original matrix after we enter the dimensions 3 by 4. And the top row is 1, 1, 1, 14. The second row is 0.05, 0.1, 0.25, 1.35, and last row 1, -2, 0, -3. And that gives us 7, 5, and 3. So 7 is the number of nickels, and 5 is the number of dimes, and 3 is the number of quarters. In number 6, one number is 2 more than a second number. Twice the first is 4 less than 3 times the second. Find the numbers. So let's let x equal the first number and y equal the second number. And the first statement is that one number is, so that means that's our first number, is equals 2 more than the second number. So that would be y plus 2. There's one equation. And then twice the first, so that would be 2 times the first number is 2 times x, is, so equals 4 less than 3 times the second. So 3 times the second is 3y. 4 less than that, we subtract 4 from it. Both of these equations have to move into standard form. So x minus y is equal to 2, and 2x minus 3y is equal to -4. Let's write this in matrix form. 1, -1, vertical line 2, 2, -3, -4 on the bottom row. Calculator will provide us with the reduced row echelon form. So RREF, open parentheses, menu key to the right of the 9. This is a 2 by 3 augmented matrix. And entering the coefficients 1, -1. Oops, I goofed. Let me use my arrow keys to go back. There's our top row. Bottom row should be 2, -3, -4. And we'll have 10 and 8. And so the first number is 10, and our second number is 8. For number 77, this speaks of the large-decked aircraft carriers, which can hold up to 72 aircraft. The Enterprise-class carrier is the longest in length, while the Nimitz is the second longest. The total length of the carriers is 2193 feet, while the difference between their lengths is only 9 feet. And so we are looking for their lengths, right? So that's at least part A. So if we let x equal the length of the Enterprise, and that would be measured in feet, and then let's let y equal the length of the Nimitz, and that would again be measured in feet. And what they tell us is that the total length of the two carriers, that would be their two lengths added together, is 2193, and the difference is 9 feet. Now we have to be careful about how we write the difference, because when we subtract, order matters. When we subtract, if the result is positive, that must be the larger length minus the smaller length, and the Enterprise, or x, represents this larger length, and that difference is equal to 9. this is a system of equations we can easily solve without resorting to matrices, but because we're asked to use matrices, we're going to go ahead and represent this as an augmented matrix and then ask the calculator for the reduced row echelon form. And RREF, open parentheses, menu key to the right of the 9, gives us a matrix. We're entering a 2 by 3. Across the top row, 1, 1, 2193, and 1, -1, 9 across the bottom row, and that is 1101 and 1092. So the aircraft are actually really close in length. We knew that because the difference in their lengths was 9. And so for part A here, our answer is the length of the Enterprise, which is the longer of the two, is 1101 feet, and the length of the Nimitz, which is the shorter of the two, is 1092 feet. Now let's look at B. B asks us to, if a football field has a length of 100 yards, determine the length of the Enterprise class carrier in terms of the number of football fields. We can just find that by dividing the length of the Enterprise by 100. So that would be 1101 divided by 100, and we don't even need a calculator for that because that's 11.01, so that's 11.01 football fields long, or it is as long as a little over 11 football fields. Number 8 is a mixture problem. For mixture problems, I like to start with a word key. And the word key here is we're talking about 4% butterfat milk and 1% butterfat milk and mixing them together. And so a percent of the milk is fat. We can call it butterfat or just plain fat. Right, so the fat content of the milk. So now I'm going to arrange this as an equation. The percent times, because of means times, the amount of milk is equal to, because is means equal in math, is the fat content. And the amount of milk and the fat content will be measured in quarts. So in a mixture problem, we're actually going to have 2 rows, one for each thing in the mixture, and the last row is for the mix. And the percent of butterfat is 4% for the first part that we're mixing together, and we don't know how many quarts of that we're going to use, but using our equation at the top, the amount of fat content is 0.04 times x. The second type that we're mixing together is 1%, or 1/100th, and that should be another amount that we don't know. Let's call it y, and the fat content of that would be 0.01 times y, and the mixture is supposed to have 2% fat, so 0.02 or 2/100ths, and it's supposed to equal 60 quarts total. And the amount of fat in that is 2% of 60. That's 0.02 times 60. So that's going to be 1.2 quarts of fat. So multiply those together. You can use your calculator to do that. And so our equation would be the total amount of milk, x plus y, has to equal 60, and the total amount of fat content, 0.04x plus 0.01y, has to equal 1.2. Let's write that in matrix form. in matrix form, 1, 1, 60, 0.04, 0.01, and 1.2. And then let's write that in reduced row echelon form. Pull up the calculator to do that calculation, and we'll type in RREF, open parentheses, and then use the matrix menu there to the right of the 9. We're entering a 2 by 3 matrix, and the original matrix, row 1 was 1, 1, 60, row 2, 0.04, 0.01, 1.2. And that'll give us 20 and 40. And so there's 20 quarts of the 4% butterfat that we're going to mix with 40 quarts of the 1% butterfat. And that's going to mix together to give us a 60 quart mixture that's 2% butterfat. In number 9, Karen Carlin bought some large frames for $50 each and some small frames for $8 each at a closeout sale. She bought 22 frames and the total price was $239. How many of each type she bought is what we're looking for. So let's call L the number of large frames and S the number of small frames. The total number of frames is L plus S. Let's put L first. Just have to be consistent, whatever we decide to do. L plus S is a total of 22 total frames. So the number of large frames plus the number of small frames is 22. And the price of the large frames, if we take $15 and multiply it by the number of large frames, that would give us how much those large frames total cost. And 8 times the number of small frames added to that should equal $239 total dollars. We can write that in augmented matrix form. And then we'll let the calculator write that in reduced row echelon form for us. Type in RREF, open parentheses, menu to the right of the 9, 2 by 3 matrix, and top row 1, 1, 22, bottom row 15, 8, 239, and that gives us 9 and 13. So that would be 9 large frames and 13 small frames. In number 10, we have in the United States, the percent of women using the internet was increasing faster than the percent of men at the start of the millennium. For the years 2000 to 2005, the function y equals 5.3x plus 39.5 can be used to estimate the percent of females using the internet, while y equals 4.5x plus 45.5 can be used to estimate the percent of males. For both functions, x is the number of years since the year 2000, and let's clarify that. We need to say that's the number of years since the beginning of the year 2000. So 0 would be right at January 1 in the year 2000. If the trend continued, we're going to predict the year in which the percent of females using the internet was equal to the percent of males. So really our system of equations is already given to us. Y equals 5.3x plus 39.5, and y is equal to 4.5x plus 45.5. We want to see the x and y that these two equations have in common. That is to say, what year were the y values equal. And so we can write that in standard form. In standard form, we're going to move our 5.3x to the other side. So negative 5.3x plus 1y is equal to 39.5, and negative 4.5x plus 1y is equal to 45.5. I just went ahead and wrote it in matrix form, and then calculator can give us that reduced row echelon form. Let's see what that gives us. So RREF for reduced row echelon form, open parentheses, menu key to the right of the 9. We need a 2 by 3 matrix, and negative 5.3, 1, 39.5 at the top, negative 4.5, 1, and 45.5 on the bottom row, and that gives us 7.5 and 79.25. And so 7.5 is the value of x, which is the number of years. And that's actually the important part of the answering the question, because they asked us to predict the year in which the percent of females using the internet was equal to the number of males. Well, if we remember that x is the number of years since the beginning of the year 2000, let's state it that way. If it's the number of years from the beginning of 2000, then that's going to fall somewhere in the middle of the year 2007. So 7.5 years after the start of the millennium, or that's going to be somewhere between the start of 2007 and the start of 2008, which is during the year 2007. For number 11, an office supply store in San Diego sells 7 writing tablets and 7 pens for $6.40. Also, two tablets and 19 pens cost $5.40. We need to find the price of each. So let's let T equal the price in dollars of the tablets. And let's let P equal the price in dollars, again, of the pens. And so in our first situation, we have 7 writing tablets and 4 pens, and our total price of $6.40. Well, the cost of 7 writing tablets is 7 times the number of tablets, and the cost of 4 pens is 4 times the price of 1 pen, and that total gives us $6.40. Second situation, if I buy 2 tablets and I add to that the price of 19 pens, I'm going to get a total price of $5.40. That is already in standard form, so in matrix form, that's 7, 4, 6.4 across the top, 2, 19, and 5.4 across the bottom. Let's let our calculator write that in reduced row echelon form. So RREF, and open parentheses, menu key to the right of the 9. We need a 2 by 3 matrix, and entering the top row, 7, 4, oops, and 6.4, 2, 9, and 5.4, and I believe I've entered something wrong because those numbers look funny. They're supposed to be the number of tablets and the number of pens. So I'm going to try to do this calculation again, and I'm going to re-enter the number that I misentered, which was I entered a 9 instead of a 19. When I re-enter that, I'm going to get something nicer. What I have is 0.8 and 0.2, and remember that is the value of T and the value of P, which is the price of the writing tablet and the price of a pen. So a tablet cost 80 cents or $0.80, and a pen costs 0.20 or 20 cents. In number 12, we have a geometry application. There is a pair of parallel lines here cut by a transversal, and we are to find the values of x and y. And one of the first things that I might notice is that we have this pair of angles right here, which are a linear pair or supplementary. So that means the sum of those degree measures must be 180 degrees. And then I also have a pair of angles that are what we call alternate interior angles, and when lines are parallel, those two angles have to have equal measures, or they are congruent. So x is equal to y minus 30. If I rewrite in standard form, that would be x plus y is equal to 180, and x minus y is equal to negative 30. And so let's put that in augmented matrix form. 1, 1, 180 across the top, 1, negative 30 across the bottom. And now we can let the calculator put that in reduced row echelon form for us. So RREF, open parentheses, and let's enter a 2 by 3 matrix. And 1, 1, 180 across the top, 1, negative 30 across the bottom. Press enter here and we get 75 and 105. And that's the value of x, that's our value of y. So I'm just going to write that. X is 75, y is 105, and we are done with that one. Number 13 is a mixture problem. We've got Gary Gunderson mixing different solutions with concentrations of 25%, 40%, and 50%. And he's looking to mix them together to get 200 liters of a 32% solution. So I like to write a word key for this. A percent of each solution is, and let's just make up something here. Maybe it's acid, that's the percent content that we're talking about. Writing that as an equation, percent times the amount of solution equals the acid content in that solution. Now, in a mixture problem, we have the things that we're mixing together, and we have the total mixture. So the three things I'm mixing together are a 25% solution, 40% solution, and a 50% solution. Don't forget to write those in decimal forms. And the mixture that we're making is a 32% solution. The amounts of each solution are not known, but the total amount of the solution, or the amount present in the mixture, is 200 liters. We can multiply to find the acid content, 0.25x, 0.4y, and 0.5z, and 32% of 200 is the acid content in the mixture. Stop, don't get your calculator. Remember, what's 32% of 100? I'm sure you said 32, so 32% of 200 is twice as much, or 64 liters of acid. So now let's write our system of equations. So the total for the amount of solution is x plus y plus z is equal to 200. The total for the acid content is 0.25x plus 0.4y plus 0.5z is equal to 64 liters of acid. And the last part is about using twice as much of the 25% solution as the 40% solution. So that would be x is twice as much, or 2 times the value of y. We're going to have to write that one in standard form, so that would be x minus 2y is equal to 0. Notice there's no z in that one. Rewriting in matrix form, 1, 1, 1, 200 across the top, 0.25, 0.4, 0.5, 64, middle row, and 1, negative 2, 0, 0 across the bottom. Let's let our calculator give us the reduced row echelon form for that. So RREF, open parentheses, and insert a 3x4 matrix here. 1, 1, 1, 200 across the top, 0.25, 0.4, 0.5, 64 on the middle row, and 1, -2, 0, 0 across the bottom row. That gives us 120s, 60, and 20. And the rest of the reduced row echelon form matrix looks like this. And so that means that we have 120 liters, I believe, yes, of the 25% solution, 60 liters of the 40% solution, and 20 liters of the 50% solution.